for this problem, we're supposed to list all possible, for each of the following polynomials, and we'll have 3 of these, we need to list all the possible rational zeros. Then after that, we're going to do synthetic division to find all of our zeros. And then third, we're going to write it as a product of linear factors. So to do the very first thing, to list the possible rational zeros, we start with P over Q in fraction form. P is all the factors of the constant. Okay, so the constant in our problem is 36, and I want to write all the factors of 36 up here in the numerator. So that's plus or minus 1, plus or minus 2, 3 goes into 36, 4 goes into 36, 5 doesn't, 6 does, 7 doesn't, 8 doesn't, 9 goes into 36, 10, 11 don't, but 12 goes into 36. And then the next number would be what? 18 goes into 36. And then the last number is 36 goes into 36. So don't forget the number itself. The denominator is all the factors of the leading coefficient. And our leading coefficient is 1, right? So down here is plus or minus 1. And that's the only number on our list. So to create your list, what you're trying to do is every combination of numerator and denominator. So I put plus or minus 1 over plus or minus 1, and then I put plus or minus 1 over the other number down here, but there's not another number down here. So whenever you have plus or minus 1 in your denominator, your list really is just your numerator. So we're going to check plus or minus 1, 2, 3, positive and negative 4, positive and negative 6, 9, 12, 18, and finally plus or minus 36. All of them, both the positive and negative. This answers question number 1. Okay, so that is the list of possible rational zeros. Now to move on to question number 2, find all the zeros. This is when you set up your synthetic division table. And no telling how long it's going to be, but the coefficients of your terms goes up here, just like when you do synthetic division. So 1 is in front of the x to the third, negative 7 is in front of the x squared, 0 for the x, and then finally the constant is 36. Now what you're checking over here is if these values are zeros. So what's going to happen is we're looking for a remainder of 0. So I'm going to check positive 1 to start with, and I'll know if it's a 0 if I get a remainder of 0. So 1 comes down. 1 times 1 is 1, plus negative 7 is negative 6. 1 times negative 6 is negative 6, plus 0 is negative 6. 1 times negative 6 is negative 6, plus 36 is 30. Now what I know is that's not equal to 0, which means 1 is not a 0 over a polynomial. And I'm going to check negative 1. So 1 comes down directly. Negative 1 times negative 1 added to negative 7 is negative 8. Negative 1 times negative 8 is negative 8 added to 0 is still negative 8. Negative 1 times negative 8 added to 36 is 28. And that's not equal to 0. Therefore, negative 1 is also not a 0 of our polynomial. Then I'm going to move on to 2. 1 comes down. 2 times 1 added to negative 7 is negative 5. 2 times negative 5 added to 0 is negative 10. 2 times negative 10 is negative 20. Added to 36 gives me 16. Again, not equal to 0. So 2 is not a 0. I'm going to check negative 2. 1 comes down. Negative 2 plus negative 7 is negative 9. Negative 2 times negative 9 is 18, plus 0 is 18. Negative 2 times 18 is negative 36, plus 36 is 0. That's great news. That means negative 2 is a 0 to this polynomial. So what we do is when we find a 0 with synthetic division, you stop and you rewrite your problem. So we're at the rewrite stage. Okay? And what's going on is this polynomial, p of x, is equal to your quotient, which is a 1, a negative 9, and a 18. But really, that's 1x squared minus 9x plus 18. Or x squared minus 9x plus 18 times your divisor, what you divided by. I know it looks like minus 2, but you really divided by x plus 2. Remember, because that's the 0 for the divisor. Then you would proceed to factor this Either use the quadratic formula if it's quadratic, or do another synthetic division table. But we have a quadratic here. And will this quadratic factor multiplies to be 18, adds to be -9? Yes, it does. Hold on just a moment. Let's get back to where we're going. There we go. Sorry about that. So this does factor. So I've got P of x is equal to x minus 3 times x minus 6. Everybody comfortable with that? I multiply those together. That gives me a positive 18. I add those together. It gives me -9. So we're right. Times x plus 2. Now this actually answers the third question. We write as a product of linear factors. There it is. The third question answered. And then the fourth question, find the zeros. Well, all we're doing is setting each one of those factors equal to 0. So I have 0 times x minus 3 times x minus 6 times x plus 2. So x minus 3 equals 0. X minus 6 equals to 0. X plus 2 equals to 0. So I get an answer of 3, positive 6, and -2. So that's all 3 of my zeros. How many zeros did I expect? I expected 3 because the degree of this polynomial is 3. So let's try this again. We want to find the list of possible rational zeros for this big polynomial. Notice it's a degree 5. So when we finish this, we're going to have 5 zeros. But first we need that possible list. So P over Q. Now P is all the factors of the constant. So we're talking plus or minus 1. 2 divides into 10. The next number that divides evenly into 10 is 5. And then 10 is the last number that divides evenly into 10. Divided by all the factors of the leading coefficient. So plus or minus 1 divides into 2. And plus or minus 2 divides into 2. That's going to give me a list. There will be fractions on this list, because anytime you have more than just 1 in the denominator, you have fractions. So my list, I put 1 over 1, that's plus or minus 1, but I need to put 1 over 2 as well, so that's plus or minus 1/2. Then I put 2 over 1, that's plus or minus 2. Then I put 2 over 2, well that reduces to 1, and it's already on the list. Okay? Then I put 5 over 1, which is plus or minus 5. 5 over 2, it's plus or minus 5/2. 10 over 1, which is plus or minus 10. And then 10 over 2 reduces to 5, and it's already on the list. So now I have a complete list of possible rational zeros. So I'm going to move on to part 2. We're supposed to find all of the zeros. Excuse me. Okay. So to do that, I have to do my synthetic division table. Across the top, I have to list my coefficients. Has to be in descending order. Notice 5, 4, 3, 2, 1 constant it is. And we're not missing any of our exponents. So I have a coefficient for all of them. That's 2, -3, -6 for my x to the third, positive 23 for my x squared, -26 for my x, and then finally, don't forget 10 down here for the constant. Now what goes in front is what you're dividing by, but list your zeros. So I'm going to do 1. Notice I don't list them all, because as soon as I find a 0 remainder over here, that means that number is a 0 and I stop the process. So I'm never going to do all of these. So the 2 comes down. D1 times 2 is 2, plus -3 is -1. 1 times -1 is -1, added to -6 is -7. 1 times -7 is -7, added to 23 is going to give me 16. 1 times 16 is 16, added to -26 is -10. And then 1 times -10 is -10, added to 10 is 0. That's awesome. That means we found our 0 of 1 right off the bat. Now it's time to stop and rewrite your polynomial. So P of x is equal to, now this is my quotient. So remember, remainder or constant x, x squared, x to the third, x to the fourth is what this would be. Or you can say, hey, I took an x to the fifth and I divided by an x to the first. So that's going to give me an x to the fourth. So I have 2x to the fourth minus x to the third minus 7x squared plus 16x minus 10 times my divisor, which is not 1, but it's x minus 1. It's always x minus this number. Okay? All right, now I'm charged with factoring this. Well, this is not, 5 terms is not something that I yet know how to factor, okay, other than using these techniques. So what I'm going to do is I'm going to do a brand new synthetic division table. Now, I'm not going to put this this polynomial at the top because it is now broken down. I'm going to put this polynomial at the top, which is essentially just these numbers we have right here. 2, -1, -7, 16, -10, which is my quotient. So 2, -1, -7, 16, -10. What am I dividing by? Okay, I need to start where I left off. Don't skip on to -1 because +1 may be a 0 again. Remember multiplicity? So the story of multiplicity tells you that you need to start where you left off, where you got a 0. So the 2 comes down. 1 times 2 is 2 plus -1 is 1. 1 times 1 is +1 plus -7 is -6. 1 times -6 added to 16 is 10. 1 times 10 is 10. Added to -10 is 0. And see, there it is. That means x equals 1 is a 0 again. I stop and I rewrite. Okay, so now I have p of x equals, well, my quotient. Okay, so again, remainder constant, x squared, x to the third. So I have 2x to the third plus 1x squared minus 6x plus 10 times x minus 1, x minus 1. Why 2x minus 1s? Because x equals 1 was a 0 twice. Now I'm working on factoring that. Now you could try factor by grouping. I'd have to factor out an x squared. I'd be left with 2x plus 1. There's no way I'd be left with 2x plus 1 here. So factor by grouping doesn't work. That's okay. We're just going to move on to another synthetic division table. I know this is a big problem. What goes there? Again, where you left off, what you're trying to break up. So 2, 1, -6, 10. Okay, so again, we're trying to break down this polynomial, which is where we left off here. Where do I start with my rational zeros list? Again, where we left off. X equals 1 might be a 0 3 times. So 2 comes down. 1 times 2 is 2 plus 1 is 3. 1 times 3 is 3 added to -6 is -3. And then 1 times -3 added to 10 is 7. Finally, that's not a 0 a third time. So the 1 is out. Now let's check -1. 2 comes down. -1 times 2 plus added. -1 times 2 is -2. Plus 1 is -1. -1 times -1 is 1 plus -6 is -5. -1 times -5 is 5 plus 10 is 15. Again, that's not 0, so -1 is out. Okay, now I'm going to check 2. Okay, 2 comes down. 2 times 2. You might be wondering why I didn't check 1/2. I don't know. I could have checked 1/2 next. Let's check 2 and then check 1/2 if they don't work. So 2 comes down. 2 times 2 is 4 plus 1 is 5. 2 times 5 is 10 plus -6 is 4. 2 times 4 is 8 plus 10 is 18. Not equal to 0. Let's try -2. Okay, so 2 is out. 2 comes down. -2 times 2 is -4 plus 1 is -3. -2 times -3 is +6 plus -6 is 0. -2 times 0 plus 10 is 10. So -2 is out. And I said, hey, let's check 1/2. You could wait till the end or go ahead and do it now. 2 comes down. 1/2 times 2 is 1 plus 1 is 2. Half of 2 is 1 plus -6 is -5. Half of -5 is -5 halves plus 10 is not equal to 0. I don't know what it is, but it's not 0. Okay, -1/2. 2 comes down. -1/2 times 2 is -1 plus 1 is 0. -1/2 times 0 is 0 plus -6 is -6. -1/2 times -6 is 3 plus 10 is not equal to 0. So all these are off the list. So we've checked 1, -1, 1/2, -1/2, 2, -2. Now let's check 5. Okay, so we've run out of space. Here's what I'm going to do is get rid of all my blue. Now remember, we've already checked plus or minus 1, 1/2, 2. So next on my list, I'm going to check 5. Then if I have to move on to 5/2 and 10, we will. But right now, in the pink, this is really where we are, because we know all of these values are not being used. So I'm going to erase this, and we're going to start fresh with 5 on my list. All right, we're ready to start with 5. Here we go. 2 comes down. 5 times 2 is 10, plus 1 is 11. 5 times 11 is 55, plus negative 6 is 49. 5 times 49 is big, plus 10 is too big. It's not equal to 0. That's what I know, right? So 5 is off. Let's check negative 5. 2 comes down. Negative 5 times 2 is negative 10, plus 1 is negative 9. Negative 5 times negative 9 is 45, plus 6 is negative 6 is 39. Negative 5 times 39 is added to 10 is not 0. That's what I know. All right, well, we're going to move on to positive 5 halves. So 2 comes down. Now, 5 halves times 2, excuse me, think about this. 5 halves times 2, the 2's cancel. It's going to give you 5. 5 plus 1 is 6. 5 halves times 6, the 2 and 6 cancels to give you 3 times 5 is 15. 15 plus a negative 6, okay, is 9. And then 5 halves times 9 is going to be, nothing cancels there. 45 halves plus 10 is not 0. And by now you ought to be getting frustrated. I'm getting a little frustrated too, but hey, this happens. 2 comes down. Now the possibility is we could have made a mistake through here, but let's knock them all out to be sure. 2's cancel. Negative 5 plus 1 is negative 4. Okay. Negative 5 halves times negative 4. Now this 2 goes into this negative 4. Negative 2 times negative 2 times. Negative 2 times negative 5 is 10. 10 plus negative 6 is 4. Okay. 2 goes into 4 2 times. 2 times negative 5 is negative 10. Negative 10 plus 10 is equal to 0. We finally found it. There it is. Okay, yay. So now we have our polynomial p of x is equal to, we're still not finished, but we have our quotient right here. Okay, so 2x squared minus 4x plus 4 times, we had 2x minus 1s, so x minus 1 times x minus 1, and now we have the new guy, x plus 5 halves. Remember, negative 5 halves was the 0, so x plus 5 halves is the factor. Now, we have got to get this guy factored out, okay, or either use the quadratic formula, because it is quadratic, and then we will have all of our zeros. So since I don't need this rational zeros list anymore, I'm going to get rid of it, okay, and then we'll come back and finish this problem. Alright, so we're trying to factor 2x squared minus 4x plus 4. A 2 comes out of there. That's x squared minus 2x plus 2. Okay, I'm trying to find numbers that multiply 2 and add to be negative 2. Doesn't happen. So I got to use the quadratic formula. X is equal to negative b plus or minus the square root of b squared, which is negative 2, minus 4 times a is 1, c is 2, and that's all divided by 2 times 1. Remember that 2 just factored out front. I'm not using that. So my A is 1, my B is negative 2, my C is 2. Follow that? Keep going. So that's going to be 2 plus or minus the square root. Negative 2 squared is 4 minus 8 over 2. Y'all, it's looking like we have some imaginary zeros here. That's the square root of negative 4 over 2. So it gives me x equals 2 plus or minus. You know this. The square root of a negative number is I. The square root of 4 is 2, so that's 2i over 2. And then I can simplify this by splitting it up into 2 separate fractions. 2 over 2 plus or minus 2i over 2, which is really 1 plus or minus I. So if I list my zeros are x equals 1, x equals 1, x equals negative 5 halves, x equals 1 plus I, x equals 1 minus I, and how many are we supposed to have? 5. 1, 2, 3, 4, 5. That is all 5 zeros. To write that as a product of linear factors, I'm going to do this at the top of the page. That would be p of x is equal to x minus 1 squared, because it showed up twice, and then x plus 5 halves, and then that 2 we factored out. That could go in the very front if you like too. And then x minus 1 minus I, and x minus 1 plus I. And that's a product of linear factors. So this is our third problem where we have to find all the possible rational zeros, then find the actual zeros, and write as a product of linear factors. So I start the process P over Q. All the factors of the constant, which is 2, goes in the numerator. So plus or minus 1, plus or minus 2. That's it. All the factors of the leading coefficient, which happens to also be 2, goes in the denominator. So that's plus or minus 1, plus or minus 2. So it turns out that the list is 1 over 1 first, so plus or minus 1, then 1 over 2, so plus or minus 1/2, then 2 over 1, which is plus or minus 2, and 2 over 2, which is plus or minus 1, and we've already got that listed. So this is your list. Okay, next you do synthetic division, and you start testing your list. So across the top, in descending order are the coefficients for your polynomial. So x to the fourth, x to the third, x squared, x constant, they're all there represented in descending order. So I'm going with the numbers in front, the coefficients. So 2, then 3, -4, -3, +2. Now down the left side, just one number at a time, the values on your list. So I start with +1. Remember, the 2 comes down directly. 1 times 2 is 2, plus 3 is 5. 1 times 5 is 5, plus -4 is 1. 1 times 1 is 1. 1 plus -3 is -2. And then 1 times -2 is -2, plus 2 is 0. So this is great. Right off the bat, we found our first 0. Okay? That means you stop and you rewrite your polynomial. Our polynomial now, it was written this way. Now we have a factor. Remember, x minus 1 is the factor, times the quotient, which is right along here. So remainder constant, x squared, x to the third. So I have 2x to the third plus 5x squared plus x minus 2. And now I start my synthetic division table again where I left off. Okay. I can make this a different color so it's a little bit clear, or more clear. There we go. Let's go with a different color, like orange. So what goes across the top is my brand new polynomial I'm trying to break down. Now, for a second, I thought we might could do factor by grouping, but that won't work. If I group these two together, I could pull out an x squared, and I'd be left with 2x plus 5. But I'm not going to be left with 2x plus 5 here, so I got to continue what I'm doing. I got 2, 5, 1, -2. That list is coming from here. 2, 5, 1, -2. Or you can pull it from here where we left off. Okay? Now my list going down the side, I have to start where my last 0 was, which is at 1. 2 comes down. 1 times 2 is 2, plus 5 is 7. 1 times 7 is 7, plus 1 is 8. 1 times 8 is 8, plus -2 is 6. So 1 is not a 0 a second time. It's still a 0, but not for a second time. I'm going to check -1. 2 comes down. -1 times 2 is -2, plus 5 is 3. -1 times 3 is -3, plus 1 is -2. And -1 times -2 is 2, plus -2 is 0. Well, yay. That means I found a second 0. Now, how many zeros are there? Well, there are 4, right? Because the degree of this polynomial is 4. So I have 2 of my zeros. Now it's time to stop and rewrite. So I have p of x is equal to the first 0 I found was 1, which gives me a factor of x minus 1. That's what we wrote here. Now I've got -1 is a 0, so that means x plus 1 is a factor, times my quotient down here, 2x squared plus 3x minus 2, right? So 2x squared plus 3x minus 2. Now, here's the deal. This is quadratic. You never have to do more synthetic division once you get down to a quadratic factor. So you can either use the quadratic formula or factor it. Nothing wrong with jumping right to the quadratic formula. In this case, A is 2, B is 3, and C is negative 2. And again, I'm using the quadratic formula to find the zeros. So I have x is equal to negative b. So it'd be negative 3 plus or minus the square root. And that's going to be of 3 squared minus 4 times a is 2. C is negative 2. And that's all divided by 2a, which is 2. Okay, our next step is just to continue simplifying that. So that's negative 3 plus or minus the square root of 3 squared is 9. 4 times 2 is 8 times 2 is 16. These two negatives right here make it a plus 16 over 4. That gives me negative 3 plus or minus the square root of 25 over 4. Now because that's a nice perfect square, what that really meant is this polynomial up here would have factored. So if you're thinking, I don't want to use the quadratic formula, I could have just factored it, you're right. That was fine. So I continue on to simplify. That's negative 3 plus or minus the square root of 25 is 5. Not 5i, just 5 over 2, which is a real number. Now I can split this up into two separate answers. One of them is negative 3 minus 5 over 4. The other one's negative 3 plus 5 over 4. That's going to be negative 8 over 4, which is negative 2, is one of my zeros. And that's going to be 2 over 4, so 1/2 is another 0. So if I just list my zeros in purple, then I have x is equal to 1, another one is negative 1, another one is negative 2, and 1/2. If I write this as a product of linear factors, that's an x minus 1. This guy is an x plus 1. This 0 leads to a factor of x plus 2. And this last 0 leads to a factor of x minus 1/2. Remember, it's always x minus the 0. So this actually answers question 2. And this answers question 3. Obviously, with all the associated work, too.